Okay, this one starts on page 104. And again, we're going to break it up over 2 days. Okay, so with this particular thing, what we're going to deal with in section 3.2 is we're going to deal with the complex number or the letter I. If you've ever noticed when you've done math in the past before, you've never had or were able to use the letter I for anything. It was always X or M or something different. There are certain letters in algebra that you stay away from. You stay away from lowercase e, lowercase I, lowercase l, and lowercase o. O and L because they look like 1 and 0. But E and I in math, lowercase, are numbers. Okay? And the first one that you're going to deal with is lowercase I. When I draw my lowercase i's, you'll always notice that I put a little tail on the end of it. That's just because so that way people don't think it's an L. But I'll always put that little tail on there. What I refers to, by definition, is the square root of a negative 1. Now, in the last couple days, you've been dealing with square rooting, some square rooting stuff, and you've always got to the point, like on the one where Bryce asked me to do today, where we had no real answer. Well, the real numbers are this family tree over here. Like the Cooks have a family tree, and they branch out. So it started with the reals, and it went irrational and rational, and so on. But the other family, the new family over here, is now called imaginary solutions. I. I for imaginary. Okay? So when you see a square root of a negative, what you're going to do is you're going to take your eyes out. Not literally. Okay? Don't do that. That'd be gross. But what you're going to do is you're going to take your eye out, and then you're going to continue to keep going with the problem. All right? So here's the way that they're going to look, at least the first few. It's going to say the square root of negative 25. In order to keep continuing with the problem, the first thing that you do is you take your eye out. Okay? If there's a negative underneath the square root, you take an eye outside first, and then you go on with whatever the square root of 25 is. Does anybody remember what the square root of 25 is? 5. We're not solving an equation, so this one would just be 5. So now, when I write that, I put it as 5i. It's also acceptable to put it as I5, but most people put the variable behind. Okay? What about the square root of negative 72? What's the first thing that you have to do? Take your eye out. And then how do I reduce the square root of 72? It doesn't come out evenly. Does 2 go into 72? How many times? 36. Does 2 go into 36? How many times? Does 2 go into 18? Does 2 go into 9? Does 3? How many times? And 3 goes in itself once. I got a pair of 3s and a pair of deuces. What does the 2 and the 3 get to do? Multiply outside or inside? Outside. What does the loner number 2 do? Goes inside. So root 2 stays inside. 6 goes outside. And don't forget you also had an I in play. Okay? Can you reduce that? Are you? No. Can you do problems like this? Are you guys okay with that? Because that's one of the parts of your assignment today is just doing that. Then, after that, they're going to talk to you a little bit about what complex numbers are. A complex number is in the form of a plus bi. The reason why it's called complex is not because it's hard, but because it has a real part and an imaginary part attached to it. The real piece is the piece that does not have an I. So this is the real part. And the I piece right here is the imaginary part. If it has an I piece, it's imaginary. If it doesn't, it's real. Now, in some of the problems, they're going to ask you to identify the real and identify the imaginary. Okay? So if I gave you something like 8 minus 2i, What's the real piece? 8. What's the imaginary piece? Negative 2i. Don't forget the sign that's in front of it. Okay? Now, what's going to happen on some of your problems also is going to say like this. 2x minus 7i is equal to 10 plus yi. And what they want you to do is find the values of x and y. Okay? So here's what I would do. The x piece is the real part. Yeah? So then you set it equal to the real piece. 2x equals 10. Solve for x. What would I do? Divide both sides by 2, and I get x equals 5. What do you think I'm going to do with the y? Same thing, right? Negative 7i equals yi. Yi yada, right? Now what? What's y equal to? The i's would cancel each other out, right? So what are you left with? Y equals negative 7. Oops. X plus 3i equals 9er minus yi iota. Thanks, Cal. Okay, so what do I do from here? X equals 9er. Okay. So if I put 3i equals negative y iota, what happens with the i's? They cancel out. And what do you get left? So I divide by negative 1, right? And I get negative 3 equals y. Good job. Are you guys okay with that? Pretty easy? Okay, good. Close. Then, let's see. Sarah, would you give me a number? 7. Bryce, give me a number.
5.
Plus 5i. Owen, would you give me another number? 9. And then, Maddie, would you give me another? Negative 3i. And then, yeah, I'm not going to ask. Let's do this. If they ask you to, or if they put an addition symbol in between there, most people screw this up because they automatically start foiling it. Is this a FOIL situation? No. 7 plus 9 is what? 16. 5i plus negative 3i is what? And done. Okay? Are you guys comfortable with adding? Yes, Tamara. 7 plus 5i minus 9 minus 3i. What if I use the same thing that they generated, and now I subtract them instead of adding them? What's 7 minus 9? What's 5i minus negative 3i? 8i. How did you get 8? Because 2 negatives, when I said it out loud, I said minus a negative. So there's 2 negative words in a row. That turns it into a positive. Some things that I've even seen some of my college kids do. Here's what they do with this one. Instead of writing it out like this, they'll get rid of the parentheses. There's nothing in the front of the first one, so they'll say 7 plus 5i. If there's a minus in here, then they'll distribute that in there to make it like this, and then they will combine like terms. That is perfectly fine with doing that. Okay, you don't. That's okay. How are you guys with adding and subtracting? Are you guys fine? Good. 7 plus 5i, 9 minus 3i. What operation am I asking you to do here? Multiplication. So this is FOIL, right? What's 7 times 9? 63, I heard. What's 7 times negative 3i? What's 5i times 9? And what is 5i times negative 3i? 15i squared. Okay, now, before we go any further, we need to talk. You guys, by the way, great job. In the initial I, what did I tell you I was equal to? Square root of negative 1. Good. So if I itself equals the square root of negative 1, what's I squared equal to? If I square both sides, what's a square and a square root do? They cancel each other out. What are you left with? Negative 1. Anytime you get I squared is actually equal to negative 1. So this really back here is negative 15 times negative 1. What's 15 times negative 1? 15. Negative 15 times negative 1 should be a positive 15. Now combine like terms. What's 63 plus 15? Good. What's negative 21i plus 45i? And what I wanted you to get to is, did you notice when I gave you the definition of a complex number, I said there was a real piece and an I piece. I never said there was an I squared piece, did I? I always said it was A plus BI. Is that form? A would be 78 and the BI would be 24i. There's no I squared in that form. So anytime when you multiply that out and you get I squared equals negative 1. Replace I squared with negative 1 and then combine like terms after that. Do you want to do another multiplication?
No.
Are you sure?
Yeah.
Okay, good. Because that's the last of it for today. Not today. So on 108 to 109, on 6 through 12, it says find the square root of the number. That's where you take your I out and then you reduce the square root if possible. Then 13 through 20 says find the values of x and y that satisfy the given conditions. That's where we just put the one piece equal to the other one. 21 to 30, that's add or subtract. And then 37 to 44 say multiply. And that's all we got today. So 6 through 42, multiples of 3.